Well, good morning all. Thank you for joining. Just as a point of housekeeping, this session will be recorded. Thank you all for joining today's Thought Leadership Forum. We're privileged to be joined by some senior representatives from Griffith University, from SafeWork New South Wales, and IRIA. My name is Gary Menzies, and I'm Managing Director at DAYWALK. I'll be chairing today's session. Today's Thought Leadership Forum is specifically focused on unpacking the key points of the new pallet racking standard, AS 4084, Part 1 and Part 2. As you might already know, Part 1 is specifically focused on design, and Part 2 on the operation and maintenance. There'll be 4 brief presentations today, and what we're hoping is you'll be able to take away at least one gem from the session, and perhaps you might be well versed in the standard already. Well, this could act as sharpening the saw. There will be a Q&A session at the end of the presentations, and we encourage you to type in any questions you do have on the Q&A tab at the bottom of the Zoom screen. At the end of the forum today, there'll also be a feedback email sent out, and anyone that sends feedback in will be sent a copy of the slide deck for future review. There'll also be a question where you might say you might like to type in a suggestion for a future thought leadership forum like today's, specifically focused on the pallet racking standard. There might be some other topic you'd like to see covered. We'd encourage you to type those suggestions in, and thank you for all the input that we are receiving. What we might do before we start off the presentation, we might just run a quick poll just to get us all on deck. Thank you very much. So just click your answer and click submit, and we'll pull up the outcome. Just give it another couple of seconds and we'll share the outcome. It's interesting. So 49% was enough to do my job, which we certainly commend everyone for that. There's a number. 26% is I'm quite familiar with racking certification. And then there's 17% that are saying very little. There's certainly a 4%, which we're glad on, that are experts. And then there's 5% that are saying nothing. So I guess, again, to say, we hope that today you can go away with some increased knowledge, and we'll crack on. So what we're going to do now is there's just a very short video which shows seismic activity. It happened in New Zealand, so you might say it's not directly applicable here. There is seismic activity in Australia as well. So it just is a warning as to the importance of compliance in racking. Thankfully, no one was killed, but it involved the collapse of an entire system. It actually happened at night. So thank you for that. We'll just play the video through briefly. So again, thankfully, no one was killed. It was a terrible, you might say, a terrible event, and huge amount of damage and wreckage. I guess it just plays the point of the importance of having an Australian standard, and that's what today's is about, is really unpacking the updated standard. Just to remind everyone, there is a Q&A tab at the bottom of the Zoom screen. Please type any questions you have, and there will be a panelist session at the end. You can answer those questions. With that, I'd like to introduce our first speaker, Dr. Benoit Gilbert. Benoit is based in Queensland. He holds a PhD on cold form steel structures from the University of Sydney, Before completing his PhD in 2010, he worked more than 3 years in the industry in Paris, designing offshore platforms. Dr. Gilbert joined Griffith University in 2010 and teaches structural engineering. At this stage, he's presently on a secondment for 2 years with Queensland Government. He's a committee member of the AS 4084 Part 1, and he's specifically in charge of Section 7, which is test methods. With that, I'd like to hand over to Dr. Benoit Gilbert. Thank you, Benoit.
Thank you, Gary. Welcome, everyone. So what I'm going to focus today is on the part 1 of the new standards, and I'm going to explain the difference between part 1 and part 2. But since 2012, the standard has been broken into 2 parts, and I'll just come back on that. So I'm going to touch in the changes in part 1, which is mainly related to design. So I know that you guys, you're not really into the design, you're more on the end user, but the message I want to convey is that the design standards is something very complex. If you think of a storage rack standards, it's extremely light compared to the weight it's carrying. So if you compare a normal building and the rack, the rack is only the self weight of the rack is negligible to the pallet's load, and it's only holding ton of materials on a sill section which is 1.2 to 2 millimeter thick. So if you compare to a building with got column which is 400 millimeter in diameter, the storage rack is extremely engineered design products. So it's very important to understand that the design part is something very complex, and that you need to leave that to some competent person and experienced person. You can't buy storage rack where are not designed correctly, because catastrophic things will happen. So I'm going to talk about the design actions, the design methodology, because Australian standard is basically the most advanced standard in the world, and some other changes and some changes in the test methodology. So next slide, please. So in the revision of the 4084, so it was decided to break down the standards into 2 parts. Part 1, which is only comply with the structural design, so what I'm going to talk about, and part 2, which is all about interaction, installation, tolerances, clearance, and maintenance that the other speaker is going to mention. So we so only going to be on part 1 this time. So next slide, please. Okay, so what is main changes, and we saw a video today, is getting some clarification for the wind and seismic design actions. So before, all those actions were referred to the common Australian standard from building. So now the storage is a bit specific, is how you the type of your load is going to have a bit of energy damping into your racks if you're storing frozen good or if you're storing liquids. So now that's taken into account into the standard. Same thing for the wind. If you're designing some clad racks, we've got design actions. So how is the load are acting on the buildings, which is very specific to the racks for safer products. Also, what has been interesting now is the design line of the racks have been clearly specified in the standards. So of course, if you design a rack or something for a building for a longer period of time, you got more chance to get a seismic event. You got more chance to get a wind, so a high wind. So you need to adapt your load depending on how long you're planning your structure to last. So now that's clearly specified. Can we get the next slide, please? And when you design your structures, you need to combine, and I'm going to show some table, you need to combine the self-weight, the wind, the seismic, there is a pallet load, the different loading pattern. You need to combine them to make sure your structure, so you're going to, basically, you're trying to get every single aspect that can occur during the life, and you try to account for. So now we've got clearly, this is how you need to design the wind and the seismic load. Next slide, please. So both for how strong it is and how much it's going to deflect. Next slide, please. So I don't want to look at a question. I just want to get basically an overhaul. Okay, so all the next 4 slides, it's now we put in the standards, we put all the different combination of load you need to consider a designer need to consider when designing a rack. So you're going to see if you can press on all the different 4 slides. It's a lot of different load combination. You need to look at a lot of different cases. So if we can go like table A, B, C, so B. So just to give a bit of an idea, this is clearly specifying the standard which note before. Next slide again, another table, I think. And then, so it just to show you that it's a very complex engineering process behind designing your racks. Next slide, please. So other changes as well, it's how imperfection are considered in the design. So you got some looseness when you install a rack, you already got a bit of imperfection, and it's very important in terms of design, because if your rack is slightly on an angle, then you got more chance of overturning. So you need to consider that into your design. And also that's been basically the equation been updated to get more precise value for the imperfection. Next slide, please. Okay, so the design methodology as well. So the Austrian standards is extremely advanced in terms of the design methodology it's using. You've got 2 ways. You can use extremely simple design method, which is going to be quite conservative, where or you can go to very advanced method where allows the designer to basically draw the a rack in CAD, with the CAD going to export everything into design software, and all the calculation will be done automatically. So it allows, and this is very unique standard in the world, to go from simple design method to very advanced method where you can really optimize your system. And it's got also using similar to the cold form steel standard in Australia, a design method called the direct stress method. This is only used in the US and Australia. It's not used in Europe, and this is a much better and accurate design method than the one used in Europe. And because storage rack got some perforation, it's very tricky to design. So the 4600, which is the cold form steel standard, has been updated and was adding more effect on the perforation on the design. So now that's been translated into the storage racks standard as well. So just for basically extra safety, more accurate design rules. Next slide, please. Okay. Some couple limitations being also removed from the standards. One is the anchor designs. They are now all the anchor designs being removed from the standards and can leave a bit more freedom for the designer to design according to the manufacturers. And also, so the interesting part with designing racks, it's the design. You base a lot of your design value from test, because it's a very complex system. So you get a lot of design value from test, which is expensive to do. So some a bit more analytical solutions have been provided, so you don't always have to do the test, but at least for some parts. Next slide, please. So we also improve the some of the testing method. As I was saying, you need to get a lot of value from your tests that you're going to input into your design. So some of them is the stiffness between the upright on the beam, it's the stiffness of the frame, and we actually giving some more method to calculate the looseness, because the looseness your connection will allow how much your rack is also going to lean on one way. So next slide, please. And this one is quite important if you got some CAD racks under a wing. The rack is going to deform in the downhill direction. And so we improve the way you can calculate the stiffness, or we can measure the stiffness of the rack in the downhill direction, which could be important if you got very tall racks or subjected to wind. So you could actually get a more precise value of the stiffness and design your racks more accurately if you prefer. Next slide, please. All right, so just to summarize my talks, there is not a lot of changes from apart from dividing into 2 parts, but on the design part, the changes are not drastic. It's just more precision, just to consider wind seismic design action, improve the equation to consider the perforation in the racks. We improve some of the test method. And one of the things that I want to repeat, this is the most advanced standard in the world for racking. And designing racking is very, very complex. So you really want to ensure that when you buy a rack, that is be designed correctly. It's not that you need to rely on people that experience and know how to design a storage racks. Thank you, Gary. Back to you.
Thank you very much, Benoit. I certainly appreciate the insights that you've shared, and it is very reassuring for the audience to know all that goes into the standard from the design aspect. So thank you, and appreciate what you've shared. Just to thank everyone already for the questions that have been chatted in, and encourage any further questions to be chatted as we go through. So with that, I'd like to introduce our second speaker, Mr. Mark Helding. Mark is based in Victoria. He has a Bachelor of Science and an MBA. Mark has been in the business for over 20 years. He's worked in supply chain for the bulk of his working career, so he has a lot of experience in this whole area. Mark was also a committee member for AS 4084, specifically Part 2, the Standards Committee. So over to you, Mark. Thank you.
Thanks, Gary. Just before I get into it, I'd just like to acknowledge the Bunurong peoples and the Kulin Nation on whose land I'm on today. We pay our respects to elders past, present, and emerging. So thank you. Next slide, please. So just a tiny little bit about us. We're the largest independent racking inspection business in ANZ. We complete over 2,500 inspections annually. Not only do we do inspections, but we do testing and training as well. So we have that capacity in Melbourne to test racking. Interestingly, little statistics, we have over 95,000 records annually of damage that we find for clients. So our database is, as you can well imagine, fairly large over the last 20 years. Next slide, please. So just a little bit, Benoit has identified that the standard was split into two. So the committee, I was specifically on Part 2. It consisted of a range of key individuals from organisations as wide-reaching as Australian Industry Group through to the regulatory authorities around the country. I was on the standard specifically to represent racking inspections and the client side of the racking inspection sector. Next slide, please. Okay, what I've tried to do here with this presentation is to highlight the key elements that operators of racking, people that use racking, really should be aware of under this new standard. So there's a lot more detail, but what I've tried to do in this short time is highlight the elements that are heavy. So one of those elements which is a theme through this is the notion of competency. So the standard refers to competency at a number of different levels, and it's a new element to standards in general, but also particularly for 4084 Part 2. And I know Joseph will talk about it as well, because this links back to the different legislations around the country. Next slide, please. So the competency exists, as I said, at a number of different levels. Annual inspections is one of those. So the person who's going to undertake your annual inspection really needs to be qualified to be doing that. So they need to have worked in the industry, been a designer or engineer or similar. They need to understand the racking that they're looking at, so the brand that they're specifically looking at, and also technically or theoretically they should be able to oversee an installation or a repair. Next slide, please. Competency also exists at a repairer level now. So basically what the standard is saying is that if you're going to have someone come onto and work on your system, they need to be competent in that system. So from that perspective, it's now an element that is referred to in the standard. I know Joseph will talk about that to some extent in his presentation. Next slide, please. So notionally, the formal inspections component has been beefed up, and in essence, racking inspections need to be undertaken. Formal racking inspections need to be undertaken every 12 months. They can be undertaken in shorter periods, so they could, for example, be done in 6 months and 6 monthly, which some clients do. But the reality is they need to be done every 12 months. The other element that's a couple of other elements that are in there is you need to be able to document the inspection, and I'll talk about that a little bit down the track. And also notionally racking systems at height. So basically in there, the third or fourth paragraph down says formal inspections over 8 metres in height should be conducted using systems such as elevated work platforms. But it also leaves it open for ground-based technology. So from that perspective, that conceptually that means, for example, technology such as drones. So we have in the past done some inspections with drones, and we found that technology quite useful for doing inspections at height. It also introduces the notion of a checklist, which is part of the standard for things that should be checked. And importantly, all inspection elements or all inspection items should be reported. All right, next slide, please. So there's also now a notion of informal inspection. So that is, as the operator of a racking system, you should be able to demonstrate that you are assessing your racking system yourself on a very regular basis. So that could be monthly, could be weekly, could be fortnightly. But either way, you should be able to demonstrate that you're checking the system beyond the normal formal inspection that you have done. Next slide, please. So retrospectivity is an interesting concept. We have this all the time with standards as they change, and that was the case with 1993 to 2012, and we now have that as the case. And it's a practical thing as much as anything else. So in this instance here, the one I've got up here, notionally under the new standard, we have load charts have new requirements. So if you're putting a load chart onto a racking system that was installed today, the requirements would be fundamentally different to what they were if they were installed in, for example, 2015. So, but there is no expectation that you would go now, based on the new standard, that you would go back and revise or remove and replace all of the load charts that you've got installed on your racking system if it was installed in 2015. There's a number of key, next click please. There's a couple of key caveats to that. So now, for example, racking systems need to be inspected every 12 months. So that is a retrospective thing. That is a thing that will follow through the racking system, regardless of its age. All right, next slide, please. So again, as I've pointed out, there's a lot of detail in the new standard, and I'm really only trying to touch on the key elements that, as operators, you should be aware of. So there's new damage types that have been included in the standard or expanded upon. So next slide, please. So beams, for example, beams were in the old standard were identified ostensibly around permanent deflection and stuff like that. However, as we know as operators, there's a range of other things that can occur to racking systems around the connectors, dents in beams, and anyone that's worked around racking will know that these are fairly common. So now these are identified within the standard. If you've had a formal racking inspection program in place, an annual one, most of these things would have been picked up and identified in your racking reports. Next slide, please. So twists is a new one that's been included. It's a common thing in Europe to be included. Within the Australian standard, it's notionally referred to around a clock type system, which is the way it's been included in the current standard. Just as a way of interest, of the 95,000 records that we collect annually, it's probably number 2 on the list of damaged items that we find. There's not a lot of testing data around twisted uprights and what happens to an upright. I've just got we were curious ourselves as to what happens to a twisted upright. So some 2 years ago, we completed our own tests around introducing various amounts of twist to an upright and so see what it does to a member or an upright when you load it up. Interestingly, what we found was that the more twist that you introduce, the more unpredictable the behaviour of the upright is. So in effect, it can collapse without any any indication of buckling or anything else. It just basically collapsed. Next slide, please. So there's been some halo changes, or what we call halo, so the spacing around a pallet. So above 6 metres, there's an extra 25 millimetres has been added to the spacing on the halo. If you've got an existing racking system, it's not a thing. There's no expectation that you go and move every beam above 6 metres up 25 millimetres. There's no expectation around that. So from that perspective, if you're putting a new system in, that would need to be considered. And the other thing that's now been included is the notion of types of pallets. So you see there in the picture, there's fanning, bulging and overhanging pallets. They all impact upon the halo or the spacing around the pallet in the racking system. Next slide, please. One of the things that has occurred or does occur is what we call the reworking of uprights. Uprights that, in extreme circumstances have been smashed back into shape with a big mesh hammer or similar. But similarly, there's been instances where bits are added to uprights to, in theory, strengthen them or rework them, as we call. So go to the next slide. So number of instances here of reworking that has occurred. Now, from our perspective, we're not saying that these are incorrect or otherwise the thing. It says that they need to be, that a competent person needs to sign off on these. And my advice to clients is if you include these things in your system and something was to happen, how have you managed your risk, or how are you going to manage your risk? And I always look at it from the perspective of, I'm standing in front of a judge, how do I explain what's happened here? So it really comes down to your appetite for risk and what you want to check. That said, repairing uprights is a hard job, and it's not easy to complete, and it is a nuisance within the overall management of a racking system. But I guess the point is you really need to do it right. Next slide, please. So OEM parts, so original equipment manufacturer versus non-OEM. So this is a thing that's now included in the standard. And this little picture here is not designed to be read easily, but the point is that when we do testing, we do some very detailed measurements on the parts that we're testing. So next click, please. Again. So in this instance here, I've just highlighted something. So when we do measurements, for example, here we've got 3 different types of beams. One of those beams is an original part versus the other 2 being non-original. And you can see there's very slight differences between the spacing, the pitch between connectors. Now, whilst that in itself might not seem like a lot, but in the instance where you insert a beam in, you might find that because of those very subtle differences, that you only have 2 connectors that are permanently in touch with the upright, so in the hole. So in effect, if you think you've got 3 connectors that are fully engaged, you've actually only got 2, or in worse, some instances you've got 1. Now, what happens in those scenarios when you load an upright up, the connector that is really joined in, the one that is in fully engaged, acts like a knife and actually will slice through the upright, which is what we found in a number of instances. So from that perspective, I guess all I'm highlighting is the fact that if you're using non-OEM parts in an OEM system, there's some risks associated with it. The standard is referring to that here. Just one more click, please. And you'll see from this with some testing we've done, the connection between a Dexian, for example, frame and a Dexian upright is considerably stronger than a non-Dexian beam to a Dexian upright. So from that perspective, what we're saying is that there's testing data to prove that the connections are better between OEM to OEM. And that kind of makes sense because they're making beams for their own system. Next slide, please. So there's been a change to load charts. There's a number of key changes, but the new standard requires that the type, which is a specific design requirement is included on the load chart. So effectively, someone can go backwards through the design process and understand under what circumstances the racking was designed for. So that's another interest. The other one is that handwritten charts are no longer part of the standard. So we've had a number of instances over the years, and particularly probably in the last 18 months, where people have bought racking off the internet and had blank load charts sent out to them, even to the extent where the people who sent out the racking refused to provide any loading data on the load chart. So basically, you can put whatever you like on the load chart. So new load chart, the new standard says they can't be handwritten, and they must be a standard size, and the location of them needs to be relevant as well. Interestingly, if you choose not to go with load charts, there are other ways now of being able to demonstrate what loading you have. Those that are warehouse people will understand that the warehouse management system might be able to cope with that. So, for example, a known slot within a warehouse location will have a loading capacity. Advanced shipping notices might let you know what that pallet has on it that's coming to you, and the warehouse management system can manage the allocations to that slot. So from that perspective, there's and stickers is one of the other things you can do. If you chose to, you could go and put stickers on your beam pairs to say what they could carry, and that's a relevant way of doing the load carrying capacity. Next slide. So another key one is that inspection records need to be kept, and they basically need to be kept for the life of the racking system. Effectively, what the standard's referring to is that you need to be able to demonstrate that it's been inspected, repaired, returned to service, and then inspected. So you need to be able to demonstrate that there's a history of maintenance on the racking system. So effectively, it's just bringing it into line with the notion of plant under the workplace legislation. So next slide, please. Then the introduction of corrosion has been brought into the standard. This is particularly around base plates and the lower sections of uprights, which are for those that work around that have racking systems will know outside that this is a problem. And interestingly, the standard, which I haven't got in here, also says that only galvanised racking should be outside. So it's brought that into line with what the industry expectations were, or industry best practices were around that. So basically now there's a corrosion element there. Next slide. So if I was to leave people with, a one-pager on what they need to do, need to make sure that there's an informal inspection process. So you're at the very least doing your inspections monthly, maybe fortnight. This is usually best done with an annual inspection report. So you'd have an annual inspection completed, they would leave a report behind. You'd be working on the racking system, constantly trying to maintain it. And the informal process is part of that. You've got to ensure that you've got in place an annual racking inspection, and it's part of a perpetual or overall process for your racking system. You need to make sure that only repairers, only people who come onto your racking are competent, so they need to know what they're doing. So don't let people work on the racking system that are not familiar with it or not familiar with what to do. Did a new load chart requirements for your load carrying capacity of your racking, and just consider the notion of non-OEM equipment as well as unconventional repairs to your racking system. So just consider that as part of your overall risk assessment of what you're doing. So back to you, Gary. Thank you.
Thank you very much, Mark. Certainly appreciate you sharing some of your experiences in the real world of racking inspections and some of the do's and don'ts, and obviously bringing it all in line with the new standard, the standard update, and specifically part 2. So thank you for that. I'd now like to introduce our third speaker, Joseph Simarina. Joe is based in New South Wales. He has an associate diploma in mechanical engineering. He also has an advanced diploma in government investigations, workplace inspection. Joe has worked 8 years as an inspector at Safe Work, New South Wales, in the engineering team in the specialist services area. Before that, he worked for 15 years with global industrial truck manufacturer, where he provided product support to the Asia Pacific region. It's of note that Joe represents Safe Work on a number of standards committees as a participating member: the steel storage racking, industrial trucks, telescopic handlers, mobile elevating work platforms, and you might say, of course, as a committee member for AS 4084 Part 2. So with that, I'll hand over to you, Joe. Thank you.
Thank you. Good morning, everyone. Good afternoon, depending on where you're from. So as mentioned, my name is Joseph Simarina. I'm an inspector or an assistant state inspector with the engineering team at Safe Work New South Wales. And today I'm going to be talking to you about pallet racking and the relevant work health and safety requirements that apply. Next slide, please. Okay, so how does it apply? So the three-tiered framework of the work health and safety laws include the Work Health and Safety Act, which is a framework to protect health and safety and welfare of all workers at work and of other people who might be affected by the work. The second level is the Work Health and Safety Regulations, which specify the way in which some duties under the Work Health and Safety Act must be met and prescribes procedural or administrative requirements to support the Work Health and Safety Act. And the third level is the Codes of Practice, which provide practical guidance on how to meet the standards set out in the Work Health and Safety Act and the Work Health and Safety Regulations, otherwise known as legislation. And these are admissible in proceedings as evidence of whether or not a duty holder under the laws, or if I can just rephrase that, whether or not a duty under the Work Health and Safety laws have been met. And thirdly, the codes of practice are not mandatory, providing that any other method used provides an equivalent or higher standard of work health and safety. And I should also note that work health and safety laws have been implemented in all jurisdictions except Victoria, which is still operating under the OH&S laws. So for any participants listening today from Victoria, please refer to your local OH&S laws and apply the relevant sections. Next slide, please. So the definition of plant in work health and safety legislation includes any machinery, equipment, appliance, container, implement, and tools, and any component of any of those things, and anything fitted or connected to those things. So plant includes items as diverse as lifts, cranes, computers, machinery, conveyors, forklifts, vehicles, mobile plant, and pallet racking. Next slide, please. Who has health and safety duties for plant in the workplace? Well, persons conducting a business or undertaking, also known as PCBUs. Secondly, PCBUs involving the management or control of plant, which is the focus of this presentation. Thirdly, designers, manufacturers, importers, and suppliers of plant. Installers and officers. Next slide, please. A PCBU involving the management or control of plant is also referred to as the person with management or control of plant, or PWMC is the abbreviation that I'll be using. The main clauses of the Work Health and Safety Regulation that apply to a person with management or control of plant can be found under Division 7, and they are Clause 203, Management of Risks to Health and Safety with Part 3.1. So effectively, Part 3.1 of the Work Health and Safety Regulation states that when managing risks to health and safety, if a duty holder cannot eliminate those risks, they must minimize those risks in accordance with the hierarchy of risk controls, which effectively is substitution, isolation, engineering controls, administrative controls, and PPE. Clause 204 requires, it's titled Control of Risks Arising from Installation or Commissioning. The person must not commission or decommission the plant unless the plant is without risks to health and safety, and that installation, assembly, construction, commissioning, etc. is done by a competent person. Clause 205 preventing unauthorized alterations to or interference with plant. So the person must prevent alterations to or interference with a plant that are not authorized by the person. Clause 206, proper use of plant and controls. This will be covered in the next few slides. Clause 207, plant not in use. So the person must ensure that plant that is not in use is left in a state that does not create a risk to the health and safety of any person. And lastly, clause 213, maintenance and inspection of plant. This will be covered in detail in the next few slides. Next slide, please. So if we look at clause 206, proper use of plant and controls, it states that a person with management or control at a workplace must take all reasonable steps to ensure that plant is only used for the purpose for which it was designed, unless that person has determined that the proposed use does not increase the risk to health and safety. And secondly, in determining whether or not the proposed use of plant increases the risk to health and safety, that person must ensure that the risk associated with the proposed use is assessed by a competent person. If you have racking in your workplace, you should always follow the instructions or information provided by the installer or the person who commissioned it. You must also ensure that pallets used are in good condition, they're compatible with the racking design, and the loads are within the safe working loads prescribed. If you deviate from these requirements or modify the racking, you must ensure that any risks that may arise are assessed by a competent person, and if required, appropriate controls are put in place to manage those risks. Now, the definition of a competent person is found under clause 5 of the Work Health and Safety Regulations. And while there are various definitions under clause 5 for a competent person, depending on the type of activity being undertaken, for pallet racking, the general definition applies. That is, a person who has acquired through training, qualification, or experience the knowledge and skills to carry out the task. Next slide, please. If we look at clause 213, maintenance and inspection of plant, it states that a person with management or control at a workplace must ensure that maintenance, inspection, and, if necessary, testing of plant is carried out by a competent person. The second part of it is that the maintenance, inspection, and testing must be carried out, firstly, in accordance with the manufacturer's recommendations, if any, or if there are no manufacturer's recommendations, in accordance with the recommendations of a competent person, or in relation to inspection, if it's not reasonably practicable to comply with paragraphs A or B, then annually. So a competent person may prescribe the requirements of maintenance and inspection for racking if there are no manufacturer's recommendations. A competent person may also refer to an applicable Australian standard, such as AS 4084 Part 2. Next slide, please. So what are the role of standards and other guidance documents under Work Health and Safety? Under Work Health and Safety legislation, there are some things that you must do, i.e. they're mandatory, and other things you must do so far as is reasonably practicable. Complying with the code of practice effectively means complying with legislation. A few standards are not mandatory in Work Health and Safety regulation. However, most standards, including AS 4084, are not. Conforming to a standard, a guide, or a fact sheet or information sheet does not guarantee compliance with Work Health and Safety legislation. However, a court may consider that conforming to a standard was relevant and that it was reasonably practicable for a person to conform to the standard in the circumstances. A Work Health and Safety inspector may also refer to a standard to identify what is known or can reasonably be expected to be known about hazards and suitable control measures to eliminate or minimize risk. And you must do what is reasonably practicable. So you may need to exceed the requirements of a standard if it is known to be deficient, and you may not need to fully conform to a standard if it is known to be excessive. Next slide, please. So for more information about finding the Work Health and Safety regulator in your state, go to the SafeWork Australia website, click on the Find Your Regulator link, and that will take you to a page with a list of work health and safety regulators in each state of Australia. Once you have gone to the relevant regulators page, simply search codes of practice, and you will get a list of codes of practices that are in your state, and then you simply just find the one that relates to plant. Thank you.
Thank you very much, Joe. Appreciate the knowledge and experience that you've shared from a government and legislative viewpoint. It certainly is important to be aware of what the requirements are. So with that, we'd like to introduce our fourth speaker, Mr. Samuel Poikael. Sam is based in Queensland. As a member of Engineers Australia, Sam is a chartered professional engineer, part of National Engineers Register in Australia. He's also an international professional engineer certified with APEC, which is the Asia Pacific Economic Corporation. Sam is engineering manager at DAYWALK. So with that, I'd like to hand over to Sam. Thank you.
Thank you, Gary, for your warm welcome, and thank you all for joining the forum today. We've just heard from some of the industry leaders on the key changes of AS 4084, steel storage racking, and I will be wrapping up today's Thought Leadership Forum by diving into the last part of the pallet racking system. As we've heard, Dr. Benoit has detailed the new design constraints specified by the first part of the standard. We've also heard from Mark and Joseph for covering the second part of the standard related to operations, maintenance considerations, and also the legislative aspects of the same. The final component of the pallet racking system is the actual pallets with the stored products. But before we jump in, let's just have a quick poll related to the racking applications. Just give it a few more seconds. Well, thank you for your time, and let's see how the polls go. Wow, that's quite interesting. So the leader is 81% using timber pallets, followed by cages and steel pallets, mesh decks, and others. Now, one of the key beauty, or to say it in a nice way, is to highlight the versatility of the pallet racking system. It's not designed for one, it is also designed for many different applications. So let's talk about the three aspects of pallet integration. Cool. The integration of the pallet and the pallet racking beams is most often overlooked, but it's quite critical. The pallets also play a key role in maintaining and prolonging a compliant racking system. Some of their methods are by providing a positive locking system, racking beam protection, fit for purpose. Let's investigate them a bit more briefly. Next, please. Cool. Positive locking, or the positive locking of a pallet simply means that the pallet not only rests on top of the beams, but is also locked onto the bearers to prevent the pallet from sliding off. Currently, Australia, being focused on safety, is a leader in its unique focus on the positive locking of pallets and cages into the racking beams. Of note, the updated standard also gives guidance on the effect that seismic activity will have on a variety of different packaging styles. To take it further, please contact a competent person for specific advice. Apart from positive locking, some pallets, could you keep the previous slide? Sorry. Yeah, apart from positive locking, some pallets also provide for self-alignment to the pallet racking beams with guiding contours to locate the pallet snugly. A compliant pallet must be certified to bear the rated loads at the point of contact while being stored on racking beams. Next, we'll look at a potential outcome of the positive locking. Yep. A potential drawback highlighted by the need of a positive locking system is the exposure of pallet racking beams from the pockets of fork tine entry. This potentially exposes the beams to be damaged or speared by the operation of the fork tines while loading or unloading. To address this concern, there are available special pallets which are designed with a gradient or a camber as a part of the underrail, which may help deflect these fork tines at the entry to protect the pallet racking beam. Now, this is especially helpful in applications where the racking beams are not easily visible during operation. Lastly, let's look at some of the fit-for-purpose pallets. A compliant racking or a certified racking is not just a wildcard pass to simply use, unload, and store any goods or products. On the contrary, it's a constraining application governor identified by load charts attached to the racking beam systems. Essentially, the compliant use of pallet racking systems is guided by an adequate understanding of the load rating per level of the racking. Apart from load rating, the chart also specifies contact types for which the racking is compliant to. So is it a uniformly distributed load, or do they come with multiple feet or concentrated feet? To work within this guidance, there are a variety of pallet types available based on requirement as well. So with heavier pallets, like the ones made of steel, it's highly beneficial to have the tear weight of the pallet indicated to be included in the SWL limit confirmations as per the charts. Next, please. Finally, just to sum up, compliance is not about using whatever is available to store a product. It's about working the entire system correctly within the limits of application to gain the benefits of the system and to develop it from there. So having a certified or a compliant racking does you no good if you misuse the pallet or product or application. Compliance must be met by the racking system on its entirety. Well, thank you everyone for your patience, and please feel free to put in any questions you have in the Q&A tab. Back to you, Gary.
Thank you, Sam. Appreciate the insights that you've shared and the important points you've covered in relation to storage mediums and product. There's one thing I'd like to just say, which is perhaps a question which is perhaps been raised already in the Q&A, but are we saying that any racking that was erected prior to 2023 must be dismantled and new racking put up? The answer is no, not necessarily. However, if you're putting in new racking or changing your racking, you want to ensure that you engage a competent person in this process. There is a final poll that we'd like to just run. The question simply is, how much did you learn? So please click your answer and click submit. Just wait a few seconds for the outcome. Well, that's good. The highest rating there, 45, was a bit, and 44% a fair bit, followed by 6% of loads, etc. So thank you for the attention. We're going to move quickly over to the Q&A session. There has been a number of questions, so we'll seek to answer them as efficiently as possible, and we'll start off. So question 1. It related back to the that video that was played, and you might be able to answer this. I'll perhaps ask both questions at the same time, question 1 and question 2. So question 1 was that racking bolted down? And question 2, was the racking used in the example in New Zealand not compliant or compliant and failed due to being subject to loads greater than what is designed in the standard? Mark, we might handball that one to you, please, sir.
Thanks, Gary. Yeah, yes, the racking was bolted down, and in relation to the racking, the magnitude of the earthquake, regardless of the design requirements. So short answer, it was a compliant it's the magnitude of the earthquake that occurred that was that issue.
Thank you very much. I might do question 3 and question 5 together as well. So I think this is at your doorstep, Mark. So do the revisions in the new standard apply to current racking, or is it grandfathered? For example, if the old standard requires 2 by anchor points per base plate, the new standard changes those requirements. Does the new requirement apply to both new and existing racking? If so, what time frame applies to upgrade to the new equipment? I might just ask question 5 the same, might say in the same breath. It appears that the new standard is clear about whether it needs to be applied retrospectively. Can someone confirm that so long as the racking is compliant to the 2012 version, is it okay, regardless of if it was installed before 2012? Over to you, Mark.
Look, from our perspective, if it was designed under the 2012 standard, then that's the design standard for it. So there would be no expectation if you choose not to upgrade anything. So from that perspective, as long as it was compliant with that standard, then that's how we would inspect. So in relation to retrospectivity, there would be no expectation that you go and put further anchors into the ground. Your case often, for example, if you only had one floor fixing in, putting a second one in could cause more damage to the concrete because of the way it's located. So from that perspective, whatever it was designed under is from our perspective would be how it would be inspected, so the standard to which it would be inspected. I think there was another question there on upright protection and that. So upright protection in the new standard or even in the old standard was broken into 2 parts. So there was rack end protection, there was upright protection. For those that are operating with racking in and around racking systems, in particular from the inspection process, often putting upright protection onto an upright is problematic because it can, in some ways, cause more damage to the upright than if it wasn't installed. The new standard is kind of a little bit grey, and it will come back down to a risk assessment. That was a deliberate thing because upright protection, as I've just alluded to, is often fraught with danger because you can actually hide damage to uprights, and it can cause more damage to uprights. So
that's good. Thank you, Mark. This one might be Mark, and Ben, I might like to chip in here as well. But with supporting and anchoring of racking, can this still be achieved with a C-section between the entire length of the front and rear posts, or has this possibility been removed within the new standard? How does this currently affect pre-existing racking that currently uses this installation?
I will flick it over to Benoit, but I'm assuming this is the case where, for example, double deep or drive-in racking, this standard doesn't apply to drive-in racking. But again, it would just come back to how was it designed? Was it designed by a competent person to do that? And my perspective, we always start from the viewpoint that it would have been designed by someone competent to behave that way. So it would be unusual that somebody's done something that is so outlandish that it's not the case. We always start from the other end. So Benoit, you may have something more to add to that.
I don't think that's been removed from the standards. I mean, the main change on the base plate, basic related to the base plate, is mainly the anchoring, because it was really the anchor bolt to the floor. The way it was designed was very restrictive, or it was basically it was too old. So we removed that. So we not really changed much on the base plate design. So I think the answer is yes, you can still do it. And then now you could really improve the way you anchoring with using different bolts or different anchor bolts than the one that was in standard. So
thank you, Benoit. And I might just while you've got the talking stick, another one for you, Benoit. It was mentioned that there are now equations for the beam to post connection stiffness in the new standard. Could you please confirm in what clause this is found? You muted, Benoit.
That's better. Yeah. So I don't have the standard in front of me, but if my memory is correct, this is in the appendixes.
The appendixes.
Yeah, that's why
Fantastic.
I'm 95% sure it's at the end of the standards.
Thank you very much. All right, we'll just quickly, here's one for you, Mark. There are several types of imported racking that have little or no branding on the racking posts and beams. Often there will be different types of racking mixed in together. What is the thought around how these racks are inspected?
I guess this goes back to competent people doing what they're doing. So, as you're correct, a lot of sites have a mixed range of racking. So it really comes down to people having the experience to be able to inspect that. Sure, if I can detail any further on that one. The question's absolutely right. I mean, so it really comes down to the person having the experience to be able to inspect that type of racking or that brand.
Yeah, that's good. That's good. And I guess one of the important things, as you've already brought in and it's been repeated a few times in today's forum, is the notion of a competent person. So the importance of, you might say, engaging competent persons. We, last couple here, is there a checklist to support the informal inspection program?
I can probably jump on that one, Gary. Yes, there is. I forget which clause it is, but there's a detailed checklist of what needs to be checked.
Good, and I might call on Benoit, and Mark might like to chip in here as well, but can you remove a beam in a string of racking and still be compliant? It would obviously differ from the load chart in such an instance, but is it okay to just remove a beam, Benoit?
On this one, I would say no, you need to go back to your engineer to make sure you can do that.
Fantastic. Well, I think that pretty well pulls up the Q&A session. So certainly appreciate everyone's input and attention. And thank you to the panelists for a very informative session. Good afternoon.